In this session we're going to look at Excel and the use of Excel for regression and correlation purposes. Now this topic is dealt with in other videos, but it does no harm to do it again. It just emphasizes the importance of the subject and also refreshes anything that's been covered before. So let's do it again. Let's say we've got time periods down here and we've got sales over here. So sales of 12 in the first month, 13 in the second month, 17 in the third month, and so on. Now what we want to do is we want to draw this, we want to represent this diagrammatically, and we want to put a trend line in to see what it looks like. Now to do this we're going to go to Insert, we'll go to Line, and we'll take the first one there. I'll just move this into the picture, and that's what we've got. Well, you can see that the blue line, which is time, that's a bit silly really, because obviously time increases as time goes by, so we'll just get rid of it. I think I shouldn't have put it in the first place. Now what we've got here is sales. That's how sales have varied as the months go by on the horizontal axis. Now I want to fit a regression line in here, a trend line, to see what it looks like. Now the easiest way to do that is just to click on the line, and you'll get these little nodes appearing on the line. Just right click on one of them. Right click and you'll see Add Trend Line. I'm using Excel 2007, by the way, so if the version you've got is different, there might be slight variation. Just click around and you'll get it to work. Alternatively, just go online, use Google, type in your question, and you'll find a lot of support on Google, people explaining how to do it. So we're just, in our case here, we'll just go to Add Trend Line, and when we do that, I'll just move it onto the screen. When we do it, we've got this one here, and it gives us various options: exponential, logarithmic, polynomial, power, moving average, and so on. I'm just going to put in the equation here as well. I want to see what it looks like, and I'll put in the r squared, although an r squared, a correlation coefficient against time, doesn't mean an awful lot. Time does not, generally speaking, determine variables. Unless I suppose you're talking about depreciation, time may be a factor, but generally speaking, time is not a good explanation for the way variables behave. So generally speaking, we don't do that. But I'm just curious. I just want to see what it looks like. So I've just put it in. Humor me. And we'll close, and we've got the equation here. Let's just put it over here. We can make that look a bit prettier, I suppose. Just make it a little bigger for a start, easier to see. And okay, so that's our equation. And as for the line itself, if you just click on the line and just click on Format the Trend Line, we will just say it's a solid line. We'll change the color to dark green, and the style will increase the weight here, or the width, to say 2.25 I should say. And let's have a look at it now. So now we can see it a bit clearer. Well, that line is pretty good actually. There are some of the original data above it, parts of it above and parts below, so it's actually a pretty good line. And the r squared actually is 0.96. It's almost perfect. If it was 1, it would be a perfect fit. And we've got the equation here as well. So we've determined that, we've worked out what that is, You can change the line, by the way, quite easily. Just click on it and format trend line and go back and try a different one. I'll just move this off the screen so we can have a look at what's happening here. We could use which one? We'll use exponential, and you can see that the exponential there. By the way, the equation has changed slightly as well, so it's not as good maybe as a fit. If you use logs, it's not good at all. That's way off. You can see there's a lot of variation here. The power, not very good. The linear seems good. The linear one is probably the best. So the sales tend to be increasing over time. That's the outcome of this one, and that's how you would fit the regression line. If we had a column for say costs or one of the other variables, we could work out the correlation. I'll just delete this for a second. Let's say we had costs, and in here we had 24, 52, 5, 16. These are very random, or as random as I can make them. It's quite boring doing this, but someone's got to do it. 39, 24, 42. This really is crazy, because they really are everywhere, and this should not be a particularly good fit. In fact, this should be a very bad correlation, or a relatively bad correlation. So here we've got this lot here. I'm just going to pick a square. I'm going to type in, I'm going to look for correlation over here. So I'm just clicked on the fx box here, which is the functions, and it brought up this one. And we can be quite lazy and just type in correl for correlation, and there you go. That's it there, and we'll click OK. Now it gives me two sets of data, so I'm going to just pick the first one, which is sales, and I'm just going to drag that down to there and say okay, that's the first one done. And now I'm going to go to costs over here. I'm going to drag that down to there, and that's done there, and I'm going to click that. So the correlation coefficient here is really bad. As I said, it's this set of figures are increasing. This one is sort of coming down, if anything. Some 14s and so on. You can see it's also negative. It's going in the wrong direction. As this one gets larger, this one seems to be getting smaller. Some quite big values at the start here and getting smaller. Clearly, if I change that to a 54 and this one here to a 48, you can see what's happening to the correlation coefficient. It's now gone positive. At least it's moving in the right direction. Let's change that to a 45. You can see now it's actually quite a good fit, or getting to be a good fit. Not surprisingly, because I'm entering the same numbers into the columns down here as over here. So 43, let's say 41, 38, 31, 34, 31, and you can see the correlation coefficients increasing all the time, because I'm making the two sets of figures the same. So we should end up with a 1, a perfect correlation. 26, that's 22, that's 21, 20, 20 again, that's gone to 60, 18, that's a 17, that's now gone to 72, this one is a 13, 97, I will make that one a 12, and it actually gives 0.99984. Well, it should be 1, but that's pretty close to 1. I'll settle for that, and we'll call it 1. So that's how you'd work out a correlation coefficient. You simply type in equal sign, correl, and the two sets of numbers, the two columns of numbers in there, and that gives you the correlation. Remember, a correlation does not indicate causation. So the amount of sales are not causing the costs here. It means that sales and costs are linked statistically. It's just the numbers happen to have that relationship. So correlation does not indicate causation. It just says that the numbers are linked, suggesting that there is causation. But it needs further inquiry as to whether it has causation or not. So we've looked at adding a trend line, and we've looked at correlation, and that's all we need to do in this one. So I'm going to leave it at that, and thank you for watching.